Okay, ladies and gentlemen, welcome to the beginning of the chapter notes for directed graphs, digraphs, and scheduling. We are speaking about a type of managerial science where we are scheduling projects or work days or workers so that we can, as efficiently as possible, complete large, complex projects. Now, these are high school level notes, so a lot of these problems are going to be extremely idealized problems, even science fiction based, such as the one on the screen now, building a dream home on Mars. But essentially what it breaks down to is we're going to have these large complex products that are made up of smaller tasks. So here we have a project that is made up of about 15, 16 tasks that would eventually result in having a dream home on Mars. So you'll notice that there are some words here that need to be defined. So in this video, we'll be going through all of the background vocabulary for these type of scheduling problems. So first of all, our project will be being completed by what are called processors. The processors will be represented with a capital P and a subscript. So the number of workers we have will depend problem to problem, but processor 1 will be referred to as P sub 1, processor 2 as P sub 2, processor 3 as P sub 3, etc. We usually probably won't have more than 3 workers, but if we had 4, it'd be P sub 4. Those are our workers. And they are, in this case, going to be all equally capable of performing any of the tasks. In other words, we don't have specific tradesmen. What we have are essentially general contractors that are equally capable of doing every task. So that's the first thing that is extremely idealized in this problem at the high school level. Secondly, we have the tasks. These are the pieces of the overall project. They will have attached to them a time that it takes to complete those. That's called the processing time, the length of time needed to complete a task. And you may have noticed that we had those tasks and those processing times listed on the previous page. In the first column was the name of the task. In the second column was a symbol for the task, and then after that symbol was a number. That number is the processing time. So, a little bit more here. Those tasks will always exist in one of 4 stages. So every task at every moment, the entire time the project is being done, would fit one of these 4 descriptions. If a task is ineligible, that means the task cannot be started. So the example I like to give for this is if you're building a home, you will not be able to paint the walls until there are walls to paint. So at the beginning of your project, you know that you eventually are going to need to paint. But you can't paint right away because you don't have anything to paint. So painting as a task would start off as being ineligible. Now, eventually, the task will be ready to begin. And in that case, it would exist in the second stage, the ready stage, which means the task could be completed, but we have not assigned it to a processor yet, and it has not been started. Third, the task could be in execution, which means the task is in the process of being completed. Meaning that it is actively being done. One of the processors is actively carrying out that task right now. And then finally, the task is complete. In other words, we have finished the task and it is no longer something we need to worry about. So again, at any time, one of those tasks will exist in one of those 4 stages. Final slide for this video. Tasks themselves, you saw on the first screen, are labeled with capital letters, usually only 1, but it could be 2 of them together, in theory, if the project was complex enough to warrant it. And as we mentioned before, every task will come with an attached. Wow, that was a terrible attempt at saying that word. Each task will have a processing time listed with the task in parentheses after the task. So this notation says that task A takes 5 units of time. And in theory, it doesn't matter what that unit of time is. It could be minutes, could be hours. Heck, we could be talking about computer processors, and it could be seconds. It doesn't technically matter. So this would say task B takes 3 units of time. Now, the last part for the high school level problems that we're going to be discussing is that once a task has been started, that task must be completed without interruption. It would help if I could spell. Must be completed without interruption. In other words, it's another thing that's very idealized about these problems in the classroom. Nothing's going to go wrong. Nothing's going to go overly right. If it says it will take 5 hours to complete the task, it will take 5 hours to complete the task. You won't run out of materials and need to go to the store again. You won't have the workday end and have to pick it back up in the morning. It is completely idealized. We are assuming that nothing will go wrong. There will be no interruptions. Once we start the project, it will be finished, and it will be finished by that same processor, and only one guy will work on each task. That is the background information for what we're getting ready to do in this unit.